for the marginal probability function. So I just put marginal probability function of random variables. This you can refer to page 83. Now for the marginal probability function, margin of x, or MOX, marginal of x, or MOX. MOX is the symbol here is f sub x sub 1x. S sub 1x. So S sub 1x is from we integrate negative infinity to infinity and lower limit to upper limit fxy. So for the marginal of x, or f sub 1x, so we integrate with respect to y. And then if you want to find the marginal of y, marginal of y, or m or y, marginal of y, so is a f sub 2y equal to the integration from negative infinity to infinity fxy. So if I want to find the marginal of y, f sub 2y, we integrate with respect to x. This is how we solve the problem here. This for the continuous. Remember, this is for the continuous property. For the discrete, we have learned already, so I do not want to discuss on the discrete. This is for the continuous property. So if you want to find margin of y, you integrate with respect to x. While if you want to find margin of x, you integrate with respect to y. This margin of x and margin of y is meant for joint property function. Okay, look at example 4.14. Example 4.14. Example 4.14. So given that the function that is fxy is equal to 3x plus yk 0 elsewhere, and then your x here is in between 0 to 5 and y is in between 0 to 4. I want to find the I want to find the value of k here. So by definition, the double integration of this function, the double integration of this function fxy dx dy must equal to 1. This is the definition. So to solve k here, we need to integrate this function. So if you integrate both function here, so I just put here double integration here. So the function there is 3x plus y multiplied by k. Let's say I integrate dx first, dx. So if I integrate dx, so my limit here is, your x limit is 0 to 5. Then I integrate with respect to y. My limit for y here is 0 to 4. And this must equal to 1. Okay. So now, if you integrate here, so first of all, I integrate with respect to x, the inner part. So if I integrate with respect to x here, so I'll get here 3x raised 2 over 2 plus by yx multiplied by k. So substitute for x from 0 to 5. And don't forget to put dy here. So we have to integrate another part here, 0 to 4. So the inside here is an integration of x and the outer part here is the integration of y. So the integration here result to, so if we integrate here, if I integrate here, I will get so the integration there become, now if I integrate there 0 to 4, so 0 to 4 y, so the integration there is just now I have integrated already. I have 3x raised to 2 over 2 plus by yx, substitute for x from 0 to 5. Here you have k here, then dy equal to 1. So you substitute there, you get 25 multiplied by 3 is 75 over 2 plus by 5y. Then don't forget to multiply by k there. Minus by, so minus by 0. Okay, then multiplied by k. So I have dy here, and here 0 to 4, and this is equal to 1. So now, so I have k there. This is refer to this part. Okay. So now the thing here is, then I need to integrate with respect to y. So I just simplify this thing here. So if you simplify this thing, okay, simplify here 0 to 4, 75 over 2k plus by 5yk dy. I want to integrate here. So if I integrate here with respect to y, I get 75 over 2 ky plus by 5y raised to over 2k. Then substitute for 0 to 4. This much equal to 1. So if we solve here, so 75 over 2 multiplied by 4, you get 150k plus by 16 over 2 is 8. 8 multiplied by 4 is 40k. 8 multiplied by 5 is 40k. So 40k, this is equal to 1. So in other words, 190k is equal to 1, and k is equal to 1 over 180. This is how you solve for k. Okay. Now from here, I want to find the value of margin of x. So now the margin of x, f sub one x is equal to the integration with respect to y. The previous function is the original function is 3x plus y k. So we integrate with respect to y, and then your y here, the limit of y there is 0 to 4. Okay. Then this can be written as 0 to 4 3x plus y, and we know that our k there is 1 over 190 dy. So if you integrate here, you integrate with respect to y. Remember, if I have dy here, we need to integrate with respect to y. Here we'll have 3xy plus by y raised to 2 over 2. Then multiplied by 1 over 190. So you substitute for 0 to 4. Okay, here we have for 4 multiplied by 3 is 12x plus by 16 over 2 is 2, 16 over 2 is 8, 10 multiplied by 1 over 180 minus by 0. This is how you solve the problem. Yeah. So the answer here is the new function here is f sub 1x is equal to this function, and this can be written as you can write here as 3xy. You can write here as okay. So you can just write here as this can be written as this function can be written as, you just put here this way. So the new function here is f1 f sub 1x is equal to 1 over 190 So you have 12x plus 2. So the limit for x here is x in between 0 to 5 and 0 elsewhere. This is how we write the margin of x. Now, let's say I want to find the margin of y. Now, margin of y, you can find the margin of y by do an integration with respect to x. The margin of y is the integration with respect. So I want to find margin of y. So margin of y is the f sub 2y. The integration with respect to x. So the function there is 3x plus yk. Your function. Now you integrate with respect to x. So if you integrate with respect to x, you just put x is from 0 to 5. So now this become so if I integrate with respect to x, I will have so I just write here like 0 to 5 here. So k is 1 over 190 is k. 3x plus y, we integrate with respect to x. Now, so if we integrate 3x here, we have 3x raised to 2 over 2 plus by integration of y is xy. Then I have here multiplied by 1 over 190. Then you substitute for x from 0 to x to 5. So this will be giving the answer of 1 over 190. So if you substitute 5 here, you get 25. 5 raised to 2 is 25. 25 multiplied by 3 is 75 over 2 plus by 5y, then minus by 0. Because of if you substitute 0 into this function, we get 0. So our new function here is 1 over 190, 75 over 2 plus by 5y. Then you can put here the margin of y here, sub 2y, f sub 2y is equal to this function. And this, so because of we are finding or we are calculating the marginal function of y, so my range here or limit here is the limit here is y in between 0 to 4 and 0 elsewhere. This is how you write a new function here, the marginal of y. Okay, the last part here, I want to find the value of property of x in between property of x in between 2 and 4 and y in between 1 and 3. So this is a quite simple way to find here. You just do a double integration here. So because of your limit here, your x limit here, so we integrate dx, then we integrate with respect to y. So our initial function here is 1 over 190. So 3x plus y. So if you integrate with respect to y, you put the limit here is for y, for x is from 2 to 4, and the outside here is for y is from 1 to 3. So if you integrate here, you integrate these functions, then I just leave to you how to integrate here. The final answer is, you can check the final answer here. The final answer here will be 22 over 95. The final answer is 22 over 95. You can integrate this function. This is how we solve the margin of x and margin of y. So I think that's all for today. So you can refer to the conditional property we will learn. The next lecture I will teach you on the conditional property function. So for this part, you can refer to, for the thing we learned just now, you can refer to exercise 4.2, page 91. You can try to solve question number 1, question number 2. There are a lot of questions there. You can solve question up to question number. Please solve, try to do it on your own. Solve question number 1, number 2, number 3, and number 4, okay, on page 91. So that's all for today's lecture. So the next lecture will discuss on the conditional property. Assalamualaikum warahmatullahi wabarakatuh.